All right, so again, sorry for that. I thought we still have 30 seconds and then I can still announce that, okay, see you guys on the part two, but put ulit. But anyway, so let's just wait maybe 1 more minute for the others. So while waiting, anyone who has a question so far? Maybe one question that you guys have in mind. So, all right. So, sir, what will happen if we started with negative upcycle? Okay. So, like what I said a while ago, if we have this kind of output, okay, so initially, if we have negative upcycle, this will become a reverse bias, right? And this will become open circuit. So it won't charge this capacitor since there is no closed loop in here. So it will only charge this capacitor right here if we have a closed loop of current in here. So in here, all of our voltage input will flow to our voltage output. So whatever is your VI, let's say a -8. So we have -8 as our first output. Okay. And then once is one positive half cycle, so we have 0, okay? And then this will be charged. And then during the negative half cycle, so again, this will become a reverse bias and open circuit. And that is the time that it will discharge the capacitor plus the value of your VI. So that is why we now have a double waveform right here. So from -8, it will become -16. Okay, so lagi namang ganun as usual kapag, inuna nyo yung, cycle na hindi pa siya magcha-charge. So that is why we always go, okay, with, half cycle where the, capacitor will be charged first. Okay. So it's just the first one that will stay as, -8, but, the others will stay -16. So dire-diretso na yun. Alright, so, any questions so far or clarification up to this point? Before we proceed to, I think this is the last example. Yeah, and then we will now proceed to clamper with biasing voltage. So any question or clarification? And if none, just give me thumbs up just to let me know that you guys are good for the first two, since those two are literally a bonus. Again, just like what I mentioned a while ago, you don't need the graph, just use this formula, okay? And then once you saw this kind of circuit, this one is a negative clamper. Okay, if we have this kind of input, okay, just double that one, then it will become a -16. So the same with positive clamper. But for this one, this will become a little bit tricky since we now again have a biasing voltage. So consider nyo pa yung positive ba siya, negative ba siya, what is the effect of that one on our diode? Okay, what if we have a higher bias voltage than a voltage input? Okay, so like those. Okay, so it seems that you guys don't have a question. So here, of course, we'll talk about passive clutter with biasing. So we have positive, positive, and then positive, negative. So shortcut ko na lang, but those are biasing voltage. And then we have negative clutter, of course, negative, positive, and then negative, negative. Okay. So let's start with positive clamper with positive biasing voltage. So a positive clamper circuit if biased with some positive reference voltage, that voltage will be added to the output to raise the clamp level. So ito meron pa rin namang like pattern, okay, or the things that in just the first glance you already know the output. Okay. So if we have positive to positive, okay, so this one is a positive clamper since if we have here positive half cycle, okay, this will become reverse bias. And then if it's a positive half cycle, so this will be or whatever is the value of this capacitor will be discharged. plus this VR will be added to this one. Okay, so that is why in here we have a little lift up. Okay, so what is this lift up right here? So this is the voltage of our bias voltage. So don't get confused with this VR. So in here they just call this one a reference voltage. So reference voltage is equal to bias voltage. Okay, so they are just the same. So we can say VR or VB. Okay. So again, I will leave the reading part to you guys. So let's just go straight with the example so that you guys can understand what's really happening in here. So I think it would be better if we will have our own explanation. Okay. So again, in here, we need to start with the cycle wherein it will charge this capacitor first. So which one? Is it positive half cycle or negative half cycle? Where do we start? Negative or positive? Anyone? Mr. Nathaniel? Mr. Tanikala? Positive. No, that's incorrect. Okay, so again, all you need to do is to base your voltage input to our diode. Hindi na dalawa. Okay, to our diode. So just check the polarity. Okay, because if it's positive half cycle, then positive to negative, and then negative to positive, so this will become a reverse bias. So our capacitor won't get charged because all of our voltage input will flow on our PO. So we should start with negative half cycle. Okay, so again, just make your diode forward bias first before yeah, because with that you'll be able to charge your capacitor. Half cycle. So in here, this will be negatively charged, okay, and this will be positively discharged. So negative to negative, positive to positive. So this will become a closed circuit. So you can do that one since this one is an ideal diode. But if this is a silicon diode, then you have to add that certain voltage. So 0.7. Okay. But since it's an ideal diode, so you can consider this one as line only. Okay. So in here, the negative of cycle, so we have a VO which is equal to 0. Okay. And VMC, okay, will be equal to our VI because it's being charged by this one. And this one now is positive VI because as soon as this will be discharged, we have a positive value of VMC. Okay. And then during the positive half cycle, so let me just erase this one. So during the paano natin ibabalik yung diode? Anyway, I can just delete this one later on. So during the positive half cycle, we now have here positive to negative and then negative to positive. So this will make this diode a reverse bias. So you can just leave this one open. And then our output right here, okay, our VO right here will be equal to VI plus this VMC right here, okay, plus this VR right here, okay. And our VMC will be coming from the negative half cycle. So that's what's happening, okay. So one more thing, why we this VR were added, okay, to our let's say voltage output during the positive half cycle. That is because just check the polarity. We have positive, and then we have positive right here, and then positive. So all of them have the same output. Okay, so the polarity of this one will be something like this. Okay, oops. So all of them, or this VI plus VMC, will meet right here, and then this VR will meet right here. So positive sign in. So that is why you have to add this VR right here. Okay. So this is the formula for the VO for the passive half cycle, and then VO for the negative half cycle. Okay. Oops. Teka lang. Seems that I made a mistake. What did I put here? VO is equal to 0. Negative, negative, positive. Yeah, I forgot. Okay, since the reading of this one is across this path right here, okay, or across this parallel path right here. So whatever is the voltage reading right here will be the same on this one. Okay, so yun yung rule ng parallel circuit natin. So in here, we have a reading of VR. Okay, so yes, we have a closed loop during the negative half cycle, but during the positive half cycle, once this one became open, so my bad, baliktad. So during the negative half cycle, okay, this will become a closed circuit, okay, and then the VO is not equal to 0 since the reading will be right here, okay, this path right here, and then the reading of this one is whatever is this VR right here. Okay. So my bad on that one. So VO on the negative half cycle is not 0, but this one is equal to our reference voltage. Okay. And then for the VO of the positive half cycle, we have here VI plus VMC, wherein VMC is equal to VI plus VR. Okay. Well, anyway, so let's have an actual example. So with that, we'll be easily understand this one's positive clamper with positive biasing voltage. So let's have this example. So calculate the V out during the positive and negative half cycle. So VI is equal to 5 volts, and then reference voltage is equal to 2 volts. Okay. So let's go straight with the solution. Oops. Okay. So again, we need to choose where this diode will become a forward bias. So in here, we need to start with negative half cycle, since at that point, this will become a forward bias, and then capacitor will be charged. So this will be charged negatively and then will be positively discharged. Okay. And then for the reading of the VO right here, so again, we read the VO on this path right here. Let's say from this node up to this node. And then the only reading is this VR right here, okay, which is equal to 2 volts. So this one is not heavily reliable, especially if this diode is not ideal. Okay, so if this is not ideal, so if let's say this one is silicon, then you have to add, you have to deduct rather, you have to deduct 0.7. Okay, so this will become positive 1.2. And then during the positive half cycle, so here you can, I think you can heavily rely on this formula right here. Except again, if we have a voltage threshold of this diode, or if this one is non-ideal, okay, just deduct that one, since the polarity of this one is negative positive. Okay, so yeah, for the voltage output, we have here VI plus VI plus VR. Okay, or you can just simply use VMC, because like there is a redundant of VI right here. Okay, magiging weird kasi kapag sinabi natin twice of VI plus VR. Well, in fact, VMC is already solved, which is equal to 7 volts. Okay, so one more thing that I forgot to discuss on this part right here is this one can be charged by 2 voltage. Okay, so na-miss ko pala tong 7 volts na to, kung bakit siya 7 volts. Okay, so let me just get this one for now. Forget that one. So during the forward bias connection, okay, we have here a negative to positive. Okay, so from here to there, it's forward bias, and then from here to there, it's also forward bias since positive is connected to positive and then negative to negative. Okay, so in here, this capacitor will be negatively charged and then positively discharged by this VI. So let's just see that VI is 5 volts, right? So we now have here 5 volts voltage. Okay, and at the same time, this reference voltage will also flow on this capacitor. So if you guys are going to take a look on the polarity, so this will be positively charged and then it will be negatively discharged if we have this polarity, right? And if you guys are going to take a look on this one, they now have the same polarity. Okay, that is why this VR right here, let's say this VR is 2 volts, okay, will be added to this 5 volts right here. Okay, so just add those two, we will have a total capacitance value of is 7 volts. Okay, so ito yung question mo, Mr. Jean Alexis. Pwede bang gawing twice of VI plus VR? So yeah, pwede naman. Kaso nga lang, it's like uh, you're confusing more your solution. Okay? Pwede naman kapag gusto mong i-simplify itong VI lang. Okay, like twice of VI plus VR. But instead of using the twice of VI, you can just directly go, with this VMC right here because VMC is equal to VI plus VR. Ito. Okay, so para dalawa lang, VI plus VMC. So in here, I've just indicated that this VMC came from this VI plus VR. Wherein, in fact, you can just put here VMC which is equal to 7 volts. Itong 5 plus 2 na to. Okay? Anyway, so that explains this capacitance value on why we have 7 volts right here. Why not only 5 volts? Why not only 2 volts? Okay, so that's because of those two voltages. Okay, so may mali din pala ako dito. So this one, tama lang. So nasabi ko naman pala nila. So during the VR is greater than VI, so capacitor is charged by VR itself. So yun yung mauuna kasi again, this one is an AC voltage. So this one will start with 0, 1, 2, and then incrementing. And then once this one become higher, VI now is greater than VR, capacitor now is charged by VI itself. Okay, so para nag-stack, 2 plus 7 is equal to 7. 2 plus 5 is equal to 7. And then for the positive half cycle, okay, so just use this formula. VO is equal to VI plus VMC, and then you will get 12 volts. So before, it's like twice of the VM only, but since, due to this VR right here, it's not twice of the VM anymore. Okay, so you have to add that reference voltage or that bias voltage. Okay, so here is the result. So it was lifted 2 volts due to this reference voltage, and then the peak voltage is 12 volts. Okay, so are we clear with this example? All right, so let's now proceed with negative passing voltage. So para hindi kayo malito, unahan ko na kayo. Dito pa lang sa positive clamper, gawin na natin kaagad yung negative bias. So if it's negative bias, all you need to do is make this one negative and this one positive, right? Yun lang naman yung pinagkaiba for this negative bias. This one is still a positive clamper, but the next example right here is a negative biasing voltage. So naging negative lang. Okay. So in here, all you need to do is check whether this one will be able to pass through this diode. Okay. So I think mahirapan pa rin. So proceed na lang tayo dito since nandito na example. Okay. So just like what I mentioned a while ago, so this will become negative and then positive. Okay. Then I will leave the reading part to you guys. And then this is what will happen. So before it was lifted, okay, to uh, above, okay, to positive, but in here it was brought down a little bit due to this reference voltage. So parang na-deduct siya or nabawas siya mismo dito sa reference voltage natin. So ito na yun. Ito yung negative part na sumagi na yan due to this biasing voltage. And then again, as usual, the same everything. I will start with negative half cycle because we wanted to charge this capacitor first. So during VI is greater than VR, capacitor is charged by VI. So diode is a closed circuit. So in here we have VMC is equal to VI minus VR. So how did that happen? So ito kasi, oops, kunin ko na lang to para mas malinis. Okay, so if you guys are going to take a look on this one, if we have this polarity, okay, so this will become a reverse bias, and then it won't be able to charge your BC right here, right? Since this one is a reverse bias. But during the negative half cycle, okay, and VI is greater than VR. So upon reaching the value of, let's say, kung ito man ay 5 volts, let's just assume that this one is 5 volts and this is 2 volts. Upon reaching a higher voltage than your VR, let's say at 3 volts, 4 volts, and then 5 volts, this will become a forward bias connection. So magiging close circuit to. Tama? And as a result, it will still flow, okay, on this VR right here. Okay? So madadaanan niya pa rin to sa loop na yan. So initially, meron tayong 5 volts. So this one is negatively charged and then positively discharged, okay, by 5 volts. So sa una lang yon. Sa una lang yon. But as time will go by, maybe after 10 milliseconds or 30 milliseconds, so sobrang bilis lang nun, this 5 volts won't last as 5 volts. Okay? Since the one that will dictate is the overall voltages that will flow on this path right here, or this closed path right here. So if you guys are going to take a look at this one, we have 5 volts, negative 5 volts rather, and then plus 2 volts. So that is why, oops, mali. Negative 5 volts plus 2 volts. That is why this will become like a negative 3 volts. Okay? So parang ito yung magiging final value ng VI nyo, which is negative 3 volts. And since this capacitor is work the other way around, so this will be charged negatively. Kung ano man yung final value natin kanina, let's say at negative 3 volts. So this will be charged negatively, and then this will be discharged positively. So that is why our VMC is equal to 3 volts. Okay, so that's what happened on why this one is 3 volts, even though initially this VR cannot pass through this side, since again this will become a reverse bias. So yeah, I hope you guys were able to get that one or need an example. So were you guys able to get the gist of this one or the idea? So rewatch nyo. Okay, so the only thing that I can advise to you guys is if we have a positive bias, okay, so VI plus VR, okay, that is the value of our VMC. Gets yun, di ba? But for the negative biasing voltage, it would be VI minus VR. Yun lang, yun na yun. Pero kung gusto nyong i-analyze step by step, just like what I discussed, so ganun yung mangyari. Okay, because if you're going to imagine how come that this VR will affect our capacitance value, well, that is because once VI became higher than VR, it will still flow on this VR right here. So we have to deduct this contradicting or opposing voltage. So Vi minus VR. And then our voltage output will be this negative VR right here, or this reference voltage. And then as usual for the passive half cycle, so this is now the time that it will discharge the capacitance value. So the formula for that one is Vi plus VMC, wherein again VMC is equal to Vi minus VR. Okay. Anyway, let's have an actual example for you guys to appreciate what's really happening with negative biasing voltage. So we have 7 volts for the Vi, okay, and then 3 volts for the reference voltage. So in here, you guys already know what is our value of our VMC. So of course, we'll start with negative half cycle, and then the value of VMC is equal to 7 minus 3. Okay, 7 minus 3 is equal to 4 volts. And then during the positive half cycle, so VMC is equal to VI, my bad, VO is equal to VI plus VMC. Okay, so 4 plus 7 is equal to 11 volts. So yeah, you can still heavily rely on our formula. Okay, it's just that how did that happen? That is the question actually. Okay, so that is why I keep on trying to explain the step-by-step scenario and how did we get this 4 volts? How did we get this at 3 volts? Okay, but for the VO right here, so this one is the same with the shunt caliper. Okay, so ito na yung idea kung bakit ang reading natin dito is equal to your VR. And then for this one, VO is equal to VI plus your VMC. Okay, so are we clear so far regarding with this example? So I can give you guys more time to reanalyze. And if ever that you have a question, so don't be shy to ask. Okay, so let me just check if you guys are still in front of your computers. So everyone, please give me a thumbs up. So except for Mr. Soriano, since I can already see him. So there is one who is not around, maybe he or she's doing something. Anyway, so yeah, that's it for this example. And then let's now proceed to positive biasing voltage. Parang naulit. Where did we start? Positive clamper with negative. And then the next one is with negative biasing voltage. Solution, negative clamper. Okay. So we're now done with positive clamper with positive and negative biasing voltage. Let's now proceed to negative clamper with positive biasing voltage. So in here, the only thing that we've changed is, of course, the polarity of this one. So in here, of course, we need to start with the positive half cycle. So actually, parang nabaliktad lang lahat eh. Okay. So again, I will leave the reading part to you guys. But here is the summary of a negative clamper with positive biasing voltage. So of course, we need to start now with positive half cycle because we need to make this one forward bias, and then in order for us to make this one a closed circuit. And with that, we'll be able to charge this capacitor. Okay. So let's discuss this one again on what's happening during the positive half cycle. So during the positive half cycle, okay, so we have here positive to negative, and then positive, negative right here. So initially, VR is of course greater than Vi, since this is an AC voltage. So it will start with 0, 1, and so on and so forth. So let's assume that this one is again 5 volts and this one is 2 volts. So where will we start? Okay, so let's just say that during VR is greater than Vi. VMC, okay, is equal to 0, since this VR right here cannot flow, or there is no flow of current on this loop right here. But once VI is greater than VR, so this will now become a forward bias, and then this 5 volts now will flow on this circuit. So this will be positively charged and then negatively charged by 5 volts. So we have negative 5. And then it will pass through this diode right here, wherein if you guys are going to take a look on this one, it will be negatively charged, okay, and then will be positively discharged. Okay, so we have here plus 2 volts. And if you guys are going to add this one, will have negative 3 volts. Okay, but since this one, again, ito yung nakakalito kasi, this one is working the other way around. Okay, so this will become positive 3 volts. So I think that part of my discussion is quite confusing. Ito na lang, para hindi magulo. So we have positive 5 volts, and then it will pass through this 2 volts. So it's 5 minus 2. Ganun na lang. Okay? 5 minus 2 is equal to 3 volts. So ito na yung final VI natin. Okay? So it will be positively charged, and then it will be negatively discharged. So that is why we have negative 3 volts. Okay? So that's what happening there. Okay, and then for the negative half cycle, of course, it's VO is equal to negative VI plus negative VI plus VR. So in here, we've just simply followed the polarities. Okay, so we have negative value of your VI, and then the value of your VMC right here, wherein it's negative. So parang ganito yung nangyari. That is why it's negative right here. Okay, well anyway, so let's have an actual example, since ito magulo lang siya kapag walang actual value. Okay, let's have this one, 10 volts, and then 2 volts for the reference of voltage. Okay, so let's start with positive half cycle first, since we wanted to make this one forward bias, and this capacitor will be charged. So let me just copy this one. So we have 10 and then 2. So we have 10 volts and then 2 volts in here. So in here, everything is the same. So once VI is greater than VR, okay, this will now become a forward bias. So there is now a flow of current. So from 10 volts, it will become 8 volts, since 10 minus 2 volts. Okay. And let's say that is our final value, okay, for this VI after passing through this VR right here. Then this will now positively charged by this 8 volts, and then it will be negatively discharged by this 8 volts also, of course. So in here, we have a value of negative 8 volts. So let's compare. There you go. Okay, so are we clear with this one on how did we get negative 8 volts? Okay, and then during the negative half cycle, so you can just use this formula. Where is that one? Okay, so hindi ko yata nailagay yung VMC. Well, anyway, so this one is the VMC itself. Okay, so negative VI plus negative VI plus VR. So negative VI is negative 10 volts plus negative 10 plus 2, which is our VMC itself. Okay, so negative 10 plus negative 8 is equal to negative 18 volts. So you can use this one, or use this formula, or use this formula. So you have 3 choices. All of them are the same. Okay. So did you guys get this one so far? Okay, so that's good. And let's now proceed to negative clamper with negative passing voltage. So in here, uh, ito na lang yung parang pinaka-last hint ko sa inyo. Kapag though, parang i-analyze nyo pa rin kasing circuit eh. So kapag positive, mag-a-add. Positive, negative, magdadadak. And then, negative, positive, magdadadak din. And then, negative, negative, mag-a-add din. So parang same sign. So that is why we have here, lifted. So nadagdag lang yung VR natin. So that is your main pattern when it comes to biasing voltage. So, well, i-check nyo pa rin kasi yung reference voltage, check nyo pa rin where will you start, positive half cycle, negative half cycle. So there's a lot of things that you need to consider. Anyway, so as time will goes by, maybe ma-figure out nyo rin yung mga techniques kung paano mag-solve ng this kind of circuit, etc. etc. Okay? So here is a summary of the negative clamper with negative passing voltage. So the best way to analyze this one is to have an actual example. So let's just assume a voltage again. Let's say this is 5 volts and this is 2 volts. So in here we have negative to negative, positive to positive. So this is forward bias for this flow of current. So in here, of course, we need to make this one forward bias also in order for us to charge this capacitor. So let's start with positive half cycle. Okay, so during the positive half cycle, VMC, okay, is equal to VI plus VR. Okay, again, this will be positively charged coming from VI, and then it will be negatively discharged, which is now equal to negative 5 volts. And since this one is forward bias also, so this will be negatively charged and then it will be positively discharged, which is now equal to negative 2 volts. Okay, so they have the same polarity for your capacitance value. So negative 2 plus negative 5 is equal to negative 7. So that is now the value of your VMC. Okay. And during the negative half cycle, so this will be discharged. So the formula of VO, okay, for the negative half cycle right here is VI plus VMC. Lagi naman ganun. Okay, and then the VO right here is equal to your negative VR. Okay, this value of this one. So let's have an actual example later on, since I guess we don't have enough time anymore. So, see you guys on part 3. Okay, baka kasi mag-close ulit. Okay, so goodbye, and let's just meet again on part 3. Goodbye.